Welcome, everyone. I'm Alfred Lammermont Weber, and today we have the extraordinary privilege to be with Professor Chandra Wickramasinghe. And I apologize for not perhaps pronouncing your name with the proper way, but Wickramasinghe. Is that correct?
No. It's a Sinhalese name, a Sri Lankan name, and it's a phonetic language. Sinhala is phonetic, so it's pronounced exactly as it's written, which is Wickramasinghe.
Well, welcome. Would you mind if I call you
Chandra?
Professor Chandra?
Yeah, much easier
from my way. Chandra is the director of the Center for Astrobiology at the University of Buckingham. And as a professor of applied mathematics and astronomy, he has taught at, among other places, University College Cardiff and the University of Cambridge. And he's the editor-in-chief of the Journal of Astrobiology and Outreach. And he's coming to us from Cardiff, Wales. Welcome.
Thank you.
And we're here, and Professor Chandra is here to lead us in a discussion of the new book that he's brought out with Robert Bauval called Cosmic Womb, The Seeding of Planet Earth, and expanding on the Panspermia theory developed by the celebrated astronomer Sir Fred Hoyle, namely that the building blocks of life were imported to Earth by comets in the distant past. The authors explore the latest findings in support of a cosmic origin for humanity. The authors explore how universal knowledge may be stored in human DNA and cells, and they posit that the ancient cultures such as the pyramid builders of Egypt and the temple builders of India, may have known a way to retrieve this knowledge. That is fascinating indeed, and we want to welcome you here, and we're all eager to learn of your discovery and your insights. So please, as I mentioned, you're in a webinar. It's as though if you could just make that you're leading one of your university seminars.
Okay.
We're all at your feet, Professor.
Well, this book and the thesis that I have been pursuing for quite a few decades now is to do with unraveling our cosmic ancestry. Okay, and the idea is that we are creatures of the cosmos, not just that our atoms came from space or from deep space or from stars, but all our genetic information was also conceived not here on the Earth, but in a really wide, huge cosmic context. So that's the grand thesis that is unfolding. And as you said in your introduction, I started my research in the 1960s, it goes back a long time now, by exploring the nature of cosmic dust. Now, if you look at the night sky, you see the huge sort of splash of stars, which makes up the Milky Way. And then in between the Milky Way stars, you see dark patches, sort of clouds like the Horsehead Nebula, huge elephants' trunks and so on, all sorts of shapes where there are no stars to be seen. And the great mystery of the 1930s and 40s was to understand why there appear to be holes in the distribution of stars. And the answer, of course, is that there are no holes in the distribution of stars. These are minute particles of the sizes of bacteria, sizes of sort of simple single cells, that are splattered everywhere in the galaxy, everywhere in the Milky Way. And it's these particles that stack up in vast quantities and block out the light of distant stars. So one of my earliest projects in astronomy, when I was getting my doctorate and so on, was to try to figure out what these dust particles are made of. The conventional wisdom at the time that I began researching on this subject was that the dust was made of ice, rather like the particles of ice that you have in the clouds, in the cumulus clouds of the Earth's upper atmosphere, tiny, tiny ice crystals. And that was sort of mainstream astronomy for nearly 2 or 3 decades when I began to explore this subject. And no sooner than I looked into this matter, it turned out that the ice grain theory was completely bogus. And it is an indication of how astronomers can be deceived by a line of investigation where everybody agrees that this is the answer to this unsolved problem, and then there's no further thinking about it. So that's the way that the dust problem had remained until I came to re-examine it. And I came to the conclusion that the ice is all wrong. There's not much in the way of ice crystals there. It's all, the dust is made of carbon. And now that was a crucial turning point in the whole story of our cosmic ancestry, because of course we know that our cells, our living cells, our bodies are made of carbon combined with other atoms, of course, but carbon is an important ingredient for the life that we have here on the Earth. Now, over the years, from the 1960s and 70s and into the early 80s, astronomy had developed to the point when people could really examine the nature of the carbon particles. Is the carbon really like graphite, or is it like carbon-60 or soot or whatever it is? And it turns out with the dawn of infrared astronomy, it's a new branch of astronomy that was developing in the 1970s, early 1980s, that when this astronomy was applied to study the dust properties, it turned out that the dust was made of organic molecules rather than carbon dust. So there was a large quantity component that was in the form of organic dust. So to cut a long story short, we had over about something like a decade, we were trying to figure out what these organic molecules are made of, or the precise compositions, how did they arise? And after a lot of searching and a lot of thinking, we decided that the most efficient way of producing this material in the quantities that existed in space was life itself. Biology was the best way that you can think of to turn out particles that are made of very complex carbon molecules, organic molecules, and essentially make identical copies, or more or less identical copies of these particles, and strew them out into space. So that was the beginnings of our theory of cometary panspermia. And then we began to look at the conventional wisdom that prevailed. How do other people think that life started on the Earth? I mean, this idea that it starts in the universe was not popular, was not in the textbooks and so on. Every textbook on biology started with the story that there was a primordial soup, and the primordial soup wasn't organic in the first instance. The organics were made by the action of lightning and ultraviolet and so on the inorganic gases that were in the atmosphere. And so you spark these gases with ultraviolet light and you make organic molecules. The organic molecules then rain down into the oceans, and the oceans then become a very dilute primordial soup. That's what it was called. And it was from this primordial soup that scientists believed that life somehow originated. Now that was in the 1930s that these theories were sort of developing, 1930s and 1940s. But actually, the whole process of thinking along that route went back very much earlier. And it went back to the great philosopher Aristotle in the 4th century BC. And what Aristotle said was that life has to start, living things have to form spontaneously from non-living matter. And one of the classic descriptions he had was, of course, of fireflies emerging from a mixture of warm earth and morning dew. If you take warm earth and morning dew and churn it and stir it around, you get fireflies. So that was the Aristotelian position, and people believed that because observations, there were no microscopes at the time and so on. And so it was very crude observations that were available up to maybe the sort of 15th, 16th centuries when AD, when microscopes and instruments like that were available. So in the early days, there were the philosophers and scientists and what they call natural philosophers were able to justify the Aristotelian position of inorganic, non-living matter just turning into life almost by a miraculous process, a magic of some kind. So people believe that. And of course, I should tell you that Aristotle is a really great philosopher. We all know that. We've been taught that Aristotle was perhaps the greatest philosopher of all time. He might have been that in terms of his logic that he developed, Aristotelian logic and so forth. But in relation to natural phenomena, he made very many mistakes. And one of the greatest mistakes he made was to postulate that the earth was at the center of the universe. And Aristotle's views prevailed for nearly a couple of thousand years before it was finally proved to be wrong by Copernicus and Galileo and Newton. And it was a great struggle by these scientists, philosophers in the 15th, 16th, 17th centuries to overturn the Aristotelian view that the earth was at the center of the universe. And it happened, though, because the evidence was irrefutable. The evidence from stars, from studying motions of planets, and then Newton came along and produced a theory that explained how all the planets went around the sun, and the Earth being the center of the solar system was just nonsense. But I mean, it's really an object lesson for us to remember that this theory, the Aristotelian theory, the Earth-centered theory, was sanctioned by all of the authorities, including the Pope, for 3 or 4 centuries or more. And it was very hard to overturn it. Now, overturning the position that the Earth was at the center of the universe, at the physical center of the universe, was accomplished, as I said, in the 17th century with Newton and so on, and Galileo, Copernicus. But the idea that life has to start on the Earth and life is centered on the Earth, that is a deeply Aristotelian position. And that has been maintained with enormous force by philosophers right through to modern times. And evidence that was going against this point of view, that evidence against spontaneous generation, appeared repeatedly in the 17th, 18th, 19th centuries, and they were always swept under the carpet. For example, in one instance, Louis Pasteur, who we regard as the father of modern biology, he found that life at a microbial level, and he had a microscope, of course. By that time, microscopes were invented, and he could see microorganisms and yeast cells and so on under the microscope. And he found, and he claimed, and he proved that life at a microbial level is always derived from life that existed before. And so he had this dictum, life from life. Life always comes from life. And he challenged the Aristotelian position of spontaneous generation. But as I said, the that dogma was so deep-rooted that nothing very much happened in the end of the 19th century. Then in the 20th century, early 20th century, a Swedish chemist, Nobel laureate, in fact, Svante Arrhenius, attempted to take up the Pasteur's position and say that life is unlikely to have started on the Earth, and that it's much more likely that life came from outside, and that microorganisms have a capacity to survive huge doses of radiation, heat and cold don't seem to kill them. And so he revived a version of what then came to be called panspermia. That also in the early 1900s didn't last very long. People were very aggressively attacked it, and there was a French team that claimed to prove that microbes are always killed when they're exposed to ultraviolet light. Totally untrue, of course. We know now that microorganisms are perhaps the hardiest life forms in the universe, and they could perhaps endure cosmic ray environments for millions, maybe even billions of years. So it was on the basis of incomplete evidence that the Arrhenius revival of panspermia was also quashed in the early 1900s. So the situation remained like that. Panspermia was unfashionable and thought to have been disproved until my colleague Fred Hoyle and I revived it in a very powerful way in the 1980s. And we argued that microbes are almost certainly present in various forms of degradation, of carbonization even, in the deep spaces between stars. In fact, the universe, we argued, was just chock-a-block with material that ultimately came from life. And how did this material come to be so extensively prevalent in the galaxy? And the answer to that was, we argued that comets are the amplifiers, the breeding ground for microorganisms, because we argued that inside of every comet, there has to be regions where liquid water prevails. The radioactive materials are present, there are warm, watery domains inside a comet, and these will be places where the microorganisms can multiply. And even if there was no water, in the deep freeze of a comet, in the icy regions of the comet, microorganisms would be preserved essentially for an eternity. So that was a theory that comets were not just the carriers of microorganisms, not just the distributors of microorganisms, but they were also the amplifiers of microbial material. So in the 1980s, in the late 1980s, or 1986 in fact, there was a return of Halley's Comet, a famous comet that was seen by Halley, and we know about it, we know a lot about Halley's Comet. It came to perihelion, as they call it, close to the sun, closest to the sun in 1986. And it was subject to astronomical observations with spacecraft, like there was a Giotto, European Space Agency spacecraft called Giotto, that went very close to the comet and took pictures and did investigations of this comet. There were telescopes that studied the dust that came out of that spewed out of the comet. And all of the observations that came from Halley's Comet showed clearly that these were not just inorganic balls of ice, or as people had thought, but they were rich in organic materials. And moreover, that there was more than a hint that bacterial cells were being thrown out of the comet. There were clear signs of such materials, biological material, showing up in certain signatures that one could detect using instruments on the telescope. So this was the first, essentially, the first sort of switch in thinking that people had to consider seriously. There was a possibility, at least, that we were right, that there was life in comets. And every single comet that was examined and studied since Halley's Comet in 1986 has taken this further in the direction of absolute proof. However, it must be, I should say, that there is still a huge amount of resistance to accepting that comets carry life. There's an acceptance now that comets carry the organic molecules that may have been the building blocks of life, but the further statement that comets actually contain living cells is still vigorously disputed in many astronomical circles, for the reason that Aristotle still prevails. Aristotle's influence from the 4th century BC still really reigns supreme in relation to biology. Biology has to start on the Earth, is the conventional wisdom. Of course, all that is complete bogus and wrong. And it's just a matter of time, I think, when people would have to hide in shame to ever believe and accept that they were thinking along these lines. Every bit of evidence that one could find from comets, from interstellar dust and so on, goes against the standard dogma that life started on the Earth and that the comets are just inorganic balls of ice or lumps of ice. That's not true at all. You have a comet, for instance, comet called Comet Lovejoy that was observed about a year and a half ago, which is spewing out a mixture of either alcohol, like the alcohol that you get in whiskey, and a sugar. And how do you get these? A mixture of sugar and alcohol is clearly a process of fermentation. And if you want to make whiskey, you put microorganisms and you have a fermentation process. And that's what's happening in these comets. And people don't want to see that even as a possibility. So the statement is, this is a very peculiar, I'm quoting the sort of astronomical establishment, a very peculiar chemistry seems to be going on in this comet, and so on. So there are too many peculiar things that are sort of piling one on top of the other. And sooner or later, I think one has to admit that the whole story has to be abandoned. And another thing that has happened recently was that we know that there was a discovery of living cells like algae on the surface of the International Space Station. Russian cosmonauts reported that about 2 years ago. They've been in a routine cleaning of the windows, the outside windows of the International Space Station. They found these microorganisms, and they were not brought from the Earth because it's regularly cleaned. And in between 2 cleanings, they found this sort of stuff just splashed onto the surface of the window, the exterior of the spacecraft window. And remember, this is at 400 kilometers above the surface of the Earth. No way in which you can get anything lofted to those heights. So this is clear indication, I think, that comets are still bringing in this material, and the data that came from the Russian cosmonauts and from the space station is clear evidence that this is the case. There's a deathly silence on the part of other investigators that are connected with the ISS. They still say that more work has to be done before we can even make a comment on this. So, I mean, whenever there is an embarrassing piece of information of that kind, the establishment just retreats. Then there is also another, really, just again a year ago or so, there was a discovery that the very oldest life on the Earth, the very oldest microbial life on the Earth, is found in rocks that are about 4.2 billion years old. Now, 4.2 billion years ago, the Earth was barely formed as a solid body. And certainly comets were impacting the Earth with great ferocity. We know that it's called the Hadean epoch, the epoch of hell on the Earth. And the rocks that formed during this epoch contains unambiguous evidence of biology. So how did that come from? They obviously came from the comets. I think there's no question that life is a truly cosmic phenomenon. And moreover, that nothing really significant happened in terms of Darwinian evolution on the Earth. Darwinian evolution was just a sort of fine-tuning. Because I'll tell you another thing. You have the first life coming on the Earth at 4.2 billion years ago, and these are microorganisms, this bacteria and archaea. They're very simple cells, no nuclei, and they remain in that form for until 2 billion years ago. So for 2.2 billion years, about half of the Earth's life, you have a habitable planet, right? And the bacteria have remained as bacteria. And if you believe the conventional story, the bacteria should have undergone mutations. The favorable mutation would have been locked into the gene, and then another mutation takes place and so on. So you should have got the whole gamut of life in various ways if you believe the standard story. So that hasn't happened. Then at 2 billion years ago, which, as I said, is over, there's 2 billion years that nothing has happened. And at that time, you have the first evidence of cells that have nuclei. They're called eukaryotes. That's the first step towards higher life, okay? That's at 2 billion years. Then these remain just similar single cells until 500,000 years, 540 million years ago, when there was a huge explosion of multicelled life, and all the little plants and animals suddenly appeared from nowhere. And so the standard picture is all absolute nonsense. What's happening is that the solar system, the Earth is exposed to an evolution of life, an evolutionary process that has taken place over billions of years, over eons of time. And we are just receiving bits and pieces whenever the Earth and the solar system encounters these new structures from very distant places, new genetic structures from very distant places. Then the other thing that is really quite interesting also is the possibility that we are the only intelligent life on the Earth. That seems to be our preferred mode of thinking. We don't like to think that there's a lot of intelligence bigger than ours or more advanced than ours in the wider universe. But if you see how the universe has evolved and how things have happened on the Earth, there's no reason to think that we are the highest in the ladder of evolution. I tend to think that we are rather at the beginning of a huge process of evolution of intelligence. Intelligence is going to be enhanced in the species that we are going to generate over the sort of millions of years that to come. And so I think that's another point of connection with our new book, The Cosmic Womb, because we argue that intelligence itself is likely to be quite widespread in the galaxy, in the universe. And if that's the case, can you countenance the possibility that such intelligent beings have, at some distant point in time, not made an attempt to encounter the Earth, to come to the Earth? I don't think the evidence for that is compelling, but I think one has to keep an open mind on that possibility, an open mind certainly on the possibility of the existence of extraterrestrial intelligence that is far above the level of intelligence that we associate with humans. There's been the SETI project, as we all know, that's started in the 1950s. It was supported by the administration, the US administration, NASA, for a while. And then they got rather fed up of it, and then it became a privately funded endeavor. And it's continued to be more or less privately or semi-privately funded right through to the present day. There's been many sort of false signals, or possibly false signals, that have been discovered in the past 50 years or so. And they have been sort of essentially ruled out as being evidence of intelligence. But now, in the last 3 or 4 years, we have found that planetary systems that can support life are really extremely commonplace in the galaxy. The Kepler satellite and the Kepler telescope, orbiting telescope, has discovered very many planetary systems that are extremely interesting, in that they have planets, not just one, but several planets that can support life. So have we then got anywhere nearer to the answering the question of whether there is intelligent life? I think at the moment it's still a case of speculation, intelligent speculation, and expectation that there might be such life. But we haven't had any hard evidence. One particular piece of discovery or piece of evidence is really interesting. October this year, there was an object that hurtled into the solar system from a distant place. It was the first positive detection of an extraterrestrial missile, huge object, under half a kilometer long or so, that came in from outside of our solar system, swung around the sun, and is now heading out towards interstellar space. And this is an object that has been called Oumuamua. It's thought to be not a comet because it hasn't produced a tail, but I personally think that it is, in fact, either a comet that has been crusted over with essentially been exposed to a long period in space and just crusted over, or it is an alien spacecraft. And I was sort of amused by the alien spacecraft possibility, because I don't attach a lot of probability to it being an alien spacecraft. But there was a similar, a cigar-shaped spacecraft that was described in Arthur C. Clarke. Because Arthur C. Clarke is a great science fiction writer, a great prophet of the future. He invented he was essentially the inventor of the communication satellite, without which we won't be on Facebook today, right? So he was a great guy, and he was a good friend of mine. He lived in Sri Lanka, and we've had many, many meetings with him. And he, in one of his books called Rendezvous with Rama, he has this cigar-shaped spacecraft that hurtles through interstellar space and lands on the Earth. So this was a sort of rather strange coincidence that it was also his 100th birthday on which this happened. So when Arthur C. Clarke celebrated he's dead, of course, a few years, but his birth centenary, this object that could be an alien spacecraft was hurtling past us. Well, I think that also more than likely is a comet that has been sort of crusted over, and for that reason has not produced a tail. And so astronomers are a bit baffled. They haven't called it a comet. So these things are coming in all the time. And I think there's no question that our solar system and the Earth has been exposed to objects from outside for as long as the planet has existed. There are 4 billion years of its existence. So we are certainly connected to space in a big way. And if, as I have argued in the new book and in many other papers and scientific papers, that life is a truly cosmic phenomenon, that life could not have originated in a small pond on the earth. It's far too complex. The whole of the universe, essentially, a very large part of the universe, was needed to put the first living system together, living system with all its possibilities locked up in various genes that are then spread around the universe in the form of bacteria and viruses. So that's the picture that is emerging, and I think we have to consider this as being a very important development in the story of human exploration of the world.
Yeah. Now, also, what is of great interest is that you argue, for example, that some ancient cultures, the Egyptians, were adamant that their ancestors came from Orion, the stars Orion, and from Sirius, and the pyramid builders of Egypt and the temple builders of India may have known what we're just now rediscovering. And you say that universal knowledge may be stored in human DNA and cells, and that the Great Pyramid is in fact a three-dimensional mathematical equation in stone, bearing a potent message for humanity across time and space. So this suggests a lot of meaning and content that is being transmitted, number one, in space, and number two, across time in history, from ancient cultures to our culture. Could you detail both of those kind of meaningful communications? That is, the one that is being transmitted through DNA in space, which is meaning, and then the meaningful communications from our ancestors, the ancient temple builders of India and pyramid builders of Egypt, to our present cultures.
Well, I think what I would say without hesitation is that these ancient peoples that you refer to, seem to have an innate knowledge of their origins, right? It seems to be almost written into their consciousness or the DNA. They knew where they came from. They knew they came from space. They knew maybe they came from, or some component of them came from a planet that orbited Sirius or Orion or something. That seems to be the implication of these ancient cultures and ancient beliefs that are quite deep-rooted in so many different cultures. But I think you got to really wonder about the nature or the mode of communication of this type of information. If there was, for instance, just for argument's sake, if you say that there was a whole packet of genes that came in the form of a virus from Sirius, or from a planet around Sirius or wherever, and got into the embryonic developing line of humans or humanoids, then that would perhaps that packet of genes would still be transmitted all the way down to us. But in the ancient Egyptians and the ancient Sumerians and the ancient Indians, they seem to have had some inkling that this was the case, that they had some ancestral connection with these distant places, faraway places. I cannot really vouch for it as being factually well established or established at all, but it's an interesting thought that if there were such inserts of genetic material that is also sort of imbued with consciousness, that we may be carrying memories of where these bits and pieces came from. I think you've got to remember that the first primates, I told you that the multicelled life emerged very subtly, sort of half a billion years ago. And what happened, that's about 350 million years ago. The first primates, which are our sort of immediate ancestors, came about 55 million years ago. Gorillas about 7 million years ago. And I'm told that Homo erectus, and that's been revised a few times, the Homo erectus ancestor of ours, which had the fairly small brain size, or just the brain size was enlarging, it was increasing at that moment in time, arrived about 1.5 million years ago. And the first humans, it's only 500,000 years ago. The first recognizable human remains about 500,000 years old. So there have been many steps in the evolution of humans up to us. And so the ancient Egyptians, the ancient Sumerians, the ancient Indians come somewhere in between that, between 500 million years ago and now. And one wonders whether the transformations that were involved in making these, or in making these modern species, did not involve inserts of genes that came from a distant place. I rather think that it probably did. I think that pure Darwinian evolution is unlikely to have produced the types of changes that are needed. That our DNA is a record of our encounters, our genetic encounters with distant life forms and even maybe distant civilizations.
I was muted, sorry.
Yeah, I couldn't hear what you were saying.
Yeah, and so what do you think of the extraterrestrial hypothesis, which may be congruent with the panspermia hypothesis, and that is that an advanced extraterrestrial civilization could as well intervene in the process with genetic experiments, say, to develop Homo sapiens through a form of cloning or genetic farming, etc.
Well, I think they are logically possible, but as far as the evidence is concerned, I don't accept the evidence that is available as being irrefutable. I think there's a lot of hype about this and so on. So I think we need more evidence.
Mm-hmm.
But in theory, if there is intelligence outside, or super intelligence outside, if that intelligence has or can in the future make contact with our planet, then anything is possible. I think we can. It's essentially H.G. Wells' War of the Worlds, isn't it? In maybe a genetic war of the worlds, but it's logically possible. But so far, the evidence is extremely circumstantial, if at all. And I think we have to bear in mind that this is just a remote possibility.
Right, right. So then, what would be what would be the strongest evidence for the panspermia hypothesis, i.e., to what degree can we point to panspermia specifically as a force or a prime mover that resulted in the end product or the intermediate product of Homo sapiens?
I think the evidence has to be genetic on the basis of the sudden emergence of different classes of genes. We know that viruses are involved in the emergence of placental mammals even before humans appeared on the scene. The appearance of placental mammals appears to be emergence of placental mammals seems to be connected with the huge viral involvement. Lots of viruses were involved in that. Then the development of higher intelligence in humans and the what's it called, the FOXP group of genes that suddenly emerged, enabling humans to communicate in speech and so forth. That emerged very suddenly, and it's almost certainly a viral insert. So viruses have been sort of intelligently within quotes, constructed viruses seem to have been involved in so-called genetic manipulation of the evolving human line. I mean, the traditional conventional wisdom was that these would be purely Darwinian processes. There's random copying errors resulted in these innovations, but I rather think that that's probably quite fanciful. There's no hard evidence for it. This most straightforward evidence is to say that these new developments were implanted in the form of viruses that came from outside, and if so, could those have been deliberately introduced? One has to keep an open mind on that.
Right. We were discussing earlier, prior to the webinar, the whole question of carbon-60, C60, and one of the reasons that I brought that up is that in 1985, of course, the Nobel Prize was awarded to the scientists who isolated certain aspects of the C60 molecule. And now there are papers which are being published which suggest multiple health benefits to the human, or at least beginning research which suggests multiple health benefits from daily ingestion of the C60 molecule in certain, whether it can be suspended in oils and certain types of oils. And I'd be happy to forward those papers to you. Could you give us a summary of the panspermia history, as it were, of the C60 molecule, how it was that the C60 molecule came to be out in space, and how it is that it arrives here on Earth, etc.?
I think there is some evidence for C60 in meteorites. That's been a claim, a fairly recent claim. But the way I see C60 emerging from panspermia is that maybe, say, if you think of biological material like viruses, the carbonaceous material with lots of carbon tied up with oxygen and nitrogen and hydrogen. If you expose these for a long enough time in space, the lowest state that you could get might be the carbon-60, C60. I originally thought that graphite would be the lowest state, that you get rid of all the oxygen and the nitrogen and so on, essentially burn up if you raise these living cells to high temperatures, that you would get graphite. But it could be that carbon-60, which is even a lower energy, which is the most stable form of carbon, would be the ultimate state. But I mean, the carbon-60 discovery was interesting because it opened the door to a huge new technology of nanotechnology, a new science of nanotechnology, and building carbon chains that have enormous strengths and so on. So it was an important development in the history of science.
Right, right. So, what would you say are the main building blocks then in the seeding of planet Earth? There's so much data here. You go into the blueprint of the Great Pyramid. You cover a tremendous amount of breadth of history of science. How would you characterize sort of the main building blocks of this, to communicate your findings broadly? Because, as you say, the establishment seems to be ignoring or even stonewalling these findings.
Well, I don't know. I think that's always been the case. Any idea that's new, and if it's any good, it's always stonewalled, isn't it? And it's neglected for quite a while. So I think there's a problem there, and also the problem that if we are going to accept this new worldview, we are going to diminish our own position in the universe. We are used to thinking that we are at the top of the pile, that humans are the most important entities in the universe, and if you accept any of the stuff that's in that book, Cosmic Womb, or any of the arguments connected with panspermia, it follows that humans are nothing. They're just irrelevant kind of excrescence in the whole situation as far as life is concerned. Life is already developed to an extremely high level, the highest possible levels already in the universe, and the Earth is just the receiving station. The Earth is getting from time to time bits and pieces of information that goes into the various life forms, and ultimately into humans, and into the evolution of humans. So it's the resistance. I think I see it as being a natural reaction to the possibility that we are not so important as we used to think we are. Human beings are always have always maintained that position of supremacy, haven't they?
Now, you go on for a history of SETI, the Search for Extraterrestrial Intelligence program, and the panspermic perspective. Could you sort of summarize that for us?
The panspermic perspective of SETI is that we have to accept that it is a certainty that life is out there, intelligent life is out there. The existence of life anywhere, and we know that life exists on the Earth, means that life is everywhere. Okay, I think that's something to stress. That people are talking about how life originated and the various chemical processes. We know nothing of those chemical processes. Every experiment that has been done to date to sort of mimic the origins of life from non-life have been a dismal failure. But we know that life is here on the Earth. We know that there is intelligence that has developed over, or been implanted, if not developed, over the last million or so years. And so it's very hard to assert that that process of progression towards high levels of intelligence would stop anywhere near the human. And I think there has to be, I mean, this may be going sort of veering towards science fiction, but the science fiction pundits like Arthur C. Clarke may not have been all that wrong. After all, many of their predictions have turned out to be right. In the case of Arthur Clarke, for instance, he predicted communication satellites. He essentially predicted the emergence of robots and so on. And so there are lots of science fiction predictions that have turned out to be absolutely correct. So I don't think it's too fanciful to take the possibility of intelligence going far above humans being possible. After all, we've been on the Earth only for 1 million years or less, or a fraction of a million years as intelligent creatures. And that's a very small fraction of the time that the universe has existed. If you believe the Big Bang Theory, 13.8 billion years. So it's a tiny time interval that we've operated within. So I think there's more than ample possibilities for considering really advanced intelligence and civilizations everywhere. But one of the questions then is that why haven't they come here? And I think they probably have already come here. We don't know. We haven't recognized them as such, recognized these visits. But that's been an argument against the whole thesis that if they're out there, why haven't they colonized us? And my answer would be that they have colonized us, but they've colonized us genetically.
That's a very interesting way of expressing it. Now, you also go back into history, and you're talking about, together with Bill Napier and Fred Hoyle, I've discussed the possibility that the history of civilization was marked by relatively recent episodes of impacts by fragments of a large comet that disintegrated when it interacted with the giant planet Jupiter 15,000 years ago. So you're talking about, he says, otherwise mysterious facts of history, the collapse of Mohenjo-Daro, the demise of the Akkad culture in central Iraq, the sudden
pyramids, and including the building of the pyramids. I mean, these are very amazing events that appear to demand some sort of recurrent catastrophic involvement of collisions. And I think collisions are also, and collisions and floods. The other interesting story is the Epic of Gilgamesh, which is dated at about 2700 BC. And the great flood that is supposed to destroy a large fraction of the life on the earth and people on the earth and so on. And this has been, again, sort of ties in with the comet collision, the fragments of comets colliding with the earth. The collapse of the Roman Empire. And there's descriptions of the sort of Arabic descriptions of events that are connected with, possibly connected with the comets. And then also there's very hard evidence from tree ring thicknesses. Every growing season, a tree develops a ring around it. And you could, if you cut through an ancient tree, the rings would tell you, the thickness of the rings would tell you how good the growing season was, how the summers were, and so on. And you find that there are periods when the tree ring thicknesses are almost zero, implying that there was a catastrophic climatic downturn. And these appear periodically, and one of the downturns is in the 5th century BC, one in the, 5th century, 500 AD, and one in the, at the time of the collapse of the the ancient cultures of India and the building of the pyramids and so on. So these are well defined in terms of the tree ring record. There have been episodes where the skies were darkened for a couple of years together, no sunlight and so on. So it's all consistent with the breakup of a giant comet and with its recurring encounters with the Earth.
Right, right. Now, have you come across information? I know that this was recounted by one of our previous guests who came across information from a Tibetan Buddhist monk of a dual sun, that every 12,500 years there's a dual sun to our sun soul, and every 12,500 years they come together, such that if you look at their twin orbits, looked at on the side, look like the infinity sign. In other words, they're both in orbits like this, and they look like the infinity sign because they're both, and that when they both come together, the force of their being together, our two suns, creates turbulence in each respective solar systems in our solar system, such that you have this. For example, the flood or the Great Flood happened about 9,500 BC, which corresponds to, that is, there's a correspondence that it's about 12,500 years ago. There are many theories, many hypotheses, but the dual sun hypothesis is one among many. Is that something that you have come across?
No, I haven't. I've heard it. I've heard seen some vague statements, but I don't know anything about it, and I haven't looked into it. No.
Right. Now, so what are the directions for our future understanding that this information is going to take us? For example, you and your co-author suggest that in the Great Pyramid of Giza, there are new facts, discoveries, and theories. Could you discuss some of these for us, please?
Well, I think on the pyramid side, I'm really at a loss to explain the details. This is Boaz's department. I'm fascinated by the pyramids. I think the pyramids have more than an indication of a cosmic connection, a cosmic context. Pyramids were probably built at the time of sort of climatic catastrophe and one of these episodes of comet collisions. Whether or not there's been actual sort of alien involvement is highly questionable. I don't think there was. I think if any alien connection was to be considered plausible, it has to be a genetic implantation of genes that had some. It's part of our genetic development, as it were. But so I don't really know a lot about the pyramids, except that I'm intrigued by the story of the pyramids, as indeed I'm intrigued by all of the ancient monuments in the Indian Indus Valley civilization. I think they're really amazing. And to find humans at that early moment in time being adept in using the calculus and using all sorts of mathematical devices that we thought was only belonged to modern times is really quite amazing. I think the Babylonians knew the calculus, and this is quite evident now. There's recent discoveries that tell us that the integral calculus, not just the differential calculus. The integral calculus was known to the ancient Babylonians, so it was not invented for the first time by Newton and Leibniz. And so all these bits and pieces of information are there. And in the pyramids also, there's a huge amount of mathematics and knowledge that is that the pyramids sort of encapsulate within themselves. But beyond that, I don't have a lot to comment on.
Yeah, well, I'm just reading, if I could, the conclusions of under the section in intelligent speculation based on cutting edge science. And he goes possibilities 1 to 5. And possibility 2 is, well, possibility 1 is that they're just coincidences. The Great Pyramid is just a tomb and nothing but a tomb. He said he discounted this one long ago. Possibility 2, it was constructed by a super genius savant. And how did that person become a savant? Possibility 3, cosmic archives. Is the universe mental? Is there a universal consciousness where all knowledge is stored, which they can access? And possibility 4 is contact, and that is the contact with a higher intelligence that downloaded this information. And possibility 5, simulated world. We reviewed earlier the very possibility that we are a simulation of a higher intelligence. We have seen how, even more bizarrely, this possibility is gaining support with top theoretical physicists and cosmologists today. I wonder if you could comment on these.
No, I think I would rather not. I think this is the reason why we separated the book into part 1 and part 2 is that Bo took responsibility 100% for what he wrote. But I don't, my sympathies are with him, but I can't vouch for the precise statements that he has made. I think there is a huge amount there that I wouldn't be able to substantiate, but my general sympathies are with the thesis that the pyramids were an important development and probably involved cosmic connection, cosmic events. But beyond that, I haven't enough knowledge.
No, sure, I understand. Here is one more paragraph that really jumped out at me, and I'm not sure, whether this, because you and your co-author really brought this book together. It is estimated that the memory capacity of a fully developed human brain is about 1 million gigabytes, compared with only 500 gigabytes for the average laptop computer of today. But it isn't just the capacity of the human brain for storing data that is impressive. The human brain can also memorize moods, ambiances, feelings, emotions, dreams, and even things that are imagined, none of which computers can do. And this brings in the whole artificial intelligence conversation. Mm-hmm. Is artificial intelligence, or is intelligence something that is carried in genes or viruses? Is that part of the panspermia?
Well, I think all of the attributes of life, human life included, is carried by viruses. Darwinian evolution is just a fine-tuning process of just minor tweaking in order to optimize connection with the environment. So most of the big developments in life and human consciousness and the evolution of the brain and so on have a deep connection with the universe. The universe is a repository of all of the knowledge about life, and I think also the repository of of consciousness, which you don't really quite understand. And religious people have various ideas about the relationship with individual humans and consciousness, individual animals and consciousness, and so on. And so there are loads, there's huge areas of absolute ignorance as far as modern science is concerned. Consciousness is still in that general area of zero knowledge in actual fact. So I think anything is possible. You can make any statement that is reasonable, and if you can justify that within some framework of logic, then that is possible. I mean, the human brain is it's just an amazing instrument, even in the way that we understand it. And in the ways that we don't understand it, it is just unimaginably fantastic. I think these are things that would be discovered in the future. But in order to discover the true nature of our being and the true nature of life, I think we have, first and foremost, we've got to accept that we are not of terrestrial origin, we didn't originate on the earth, and that we have a cosmic pedigree. And the cosmos is the birthplace of all of the information that went into our living cells, and consciousness is part of it, which we are still grappling with in order to understand.
Yeah, and one interesting case that you cite is that of the evolution of the squid to the octopus, for example.
Yeah, that is an amazing story that has only been unraveled in the last 2 or 3 years, because gene sequencing is relatively recent, modern, right? In the year 2000, it was as recent as that the entire human genome was sequenced, right? We know you can give a sample of your tears or sputum and get the whole of your genome sequenced now. And it was a tedious process at the beginning, but now it's almost routine for all sorts of things, for criminology, for science, and so on. So what's happened now is that the DNA of insects, of squid included, of animals, many of these have been completely sequenced. And what was really surprising has a huge number of brain chemicals, right? The human genome has only 25,000 genes coding for proteins. The squid has double or even more that number, or greater number of genes, and a large fraction codes for sort of higher function of the brain. So they have an enormous capacity. I think they're possibly the cleverest creatures on our planet, though we can't talk with them. And the way they camouflage and the way they do things and so on, I think that it's an amazing story.
Right. Exactly. Now, you also talk about stratospheric experiments to test panspermia. Could you speak about those?
Yeah, we have, from the time that we decided that this has to be a serious proposition, that life came from outside, is more than a sort of trivial theory. We had to devise experiments to prove it. And one of the experiments that we devised was to send balloons to the high stratosphere and collect material in a sterile, aseptic way, bring it down to Earth and see what's there, whether there are microorganisms. We did this for the first time in collaboration with the Indian Space Research Organization in 2001. And the results were just staggering. We found that there was a huge number of microorganisms that we could not culture, but we knew they were there because there were tests that we were able to perform to show that they were unculturable microorganisms. There were a few that were cultured, similar, and they turned out to be similar or related to Earth organisms, but there was a huge number that was not culturable. We were able to estimate the total infall of this material to the earth, because we take a little sample and we can extrapolate from that sample how much is falling on the earth on any given day, and it turns out to be tons of material falling on the earth, tons of biological material. And this was, of course, a bombshell that essentially scared the mainstream scientists, because if this is true, then we've got to really watch out for all our epidemics and so on, which I think also came from space. But so they had to devise some argument to say that they had to explain this some other way, and the instant rebuttal was that these must have been contaminants, either laboratory contaminants or they were lofted from the ground. Now, lofting from the ground, you can think of winds and volcanic eruptions and so on. There were no volcanic eruptions at the time that we did this experiment, but the highest levels, heights that microbial material can be lofted turns out to be, you can prove it sort of mathematically, it turns out to be about between 10, 15 kilometers. Now, we were at 40 kilometers, and we're finding these things at 40 kilometers. So that was, I think that there was no possibility that these were contaminants, but the general sort of, reaction to ignore the result was to say that they are contaminants. Now, as I told you earlier, there's a discovery reported by the Russians that at 400 kilometers, the International Space Station has bacteria and algae that have been discovered, essentially splashed onto the windows from time to time. And so how can they explain that? And then that's almost impossible. But there's a deathly silence on this matter. At the moment, a year and a half has lapsed from the time that the Russians announced this, and still we don't have a clear explanation for what it means. And the Russians are quite clear. They say that these are microbes that came from comets and so on. But of course, there's a standoff between you guys in the United States and the Russians, aren't there? Isn't there?
Well, I'm not part of that.
I know. Some of you would say it's fake news.
Right. Exactly. Well, you know, I'm parts of I mean, I found, for example, your passages on cosmic coincidence, God's creation, and consciousness very interesting. For example, rebirth in Buddhism, the cases of Mozart and the Indian mathematical prodigy Srinivasan Ramanujan.
Yeah. I mean, those are really very hard to explain. I mean, we talked briefly about consciousness and about these higher levels of intelligence that are implied in the pyramid construction and so on. So these have to be explained somehow. And I think the idea that there is a enormous storehouse of knowledge in consciousness, and that these could be passed on from one person to another, or one rebirth to another, and so on, or from one planetary abode to another. All these have to be taken at least semi-seriously, I think. We can't really ignore these as just impossible things. I mean, how do you explain those coincidences with the geniuses, the sudden emergence of genius? And it's not only those two people. I mean, we've got loads of stuff through history, isn't it, that keep on telling the same story.
So how would you say that these insights connect to your understanding of panspermia? Is there a connection there?
Well, I think panspermia, in its broadest interpretation, says that all of life, everything that's connected with life and consciousness, has to have a cosmic provenance. the cosmos is the repository of all life and of all knowledge, of all consciousness. I mean, in a sense, it is part of a sort of religious theme as well, isn't it? Every philosophy, every ancient religion asks the same questions. Where did we come from? What are we here for? And where are we going? And I think Panspermia answers all of these in a rational, or attempts to answer them in a rational way. We came from space, we are here on the earth, and we recycle the knowledge that we acquired from numerous trillions of other places, and we send it back to space, ultimately. We return to space. There's a return at the end of the day, but the return is to a cosmic environment.
Yeah. For example, a scientist from the University of Washington, Professor Dr. Carl Johan Kalaman, was on our program recently, and he has produced a series of very interesting books, one of which talks about the intentional universe. And that is that the concept that the universe itself has a mind, like any other physical body, and that panspermia is not random and chaotic. Rather, the mind of the universe in its broadest sense. I mean, and in his more recent book, he gets in more detail in some of the actual mathematical formulas that and cycles that govern the disbursement of meaning and content throughout the universe. And I commend his books to you. But it seems to me that he was going along a valid direction, taking your insights here and then saying, yes. I mean, not that he did that in his book, but he said, look, we're living inside of an intentional universe. That is, if you look at the entire universe, it's not chaotic. There's an intention here. And he went about to prove it. And there's a series of equations. The title of his most recent book is The 9 Waves of Creation. And he shows the different 9 waves that took place in the creation process, and which can relate to the panspermia theory. I believe one could integrate the two theories in that there's a congruency there. So without getting into the details, do you think that there's room there for an intentional universe, or a non-chaotic process, or an intentional process that is behind panspermia, so its patterns are actually proceeding according to some intelligent form of the, you say cosmic womb. I mean, that in itself implies intention, because you're using a womb is sort of an intentional, there's intention to that.
Yeah.
That's a metaphor to an organ, or to the seeding of planet Earth, that there's intention implied in those words. And I wondered if you could just go into that as a thought and a philosophy.
Well, I think there'll be many ideas relating to the universe being an intentional construct, isn't it? That the idea that you mentioned this, that it is a simulation, that we are essentially living in the simulation of some intelligent entity. The idea that an intelligence put everything together is also very sort of logically very enticing. Because if you think of ourselves, and if you think of the development of human intelligence, at the present time, we can do a lot of genetic engineering, right? We can take a bacterium, make a splice another gene into it and change it and so on. So just imagine in maybe 200 years from now, we could construct a whole suite of biological forms that we think are interesting, and we want to spread them in space and make a universe full of these new life forms. And that's the easiest thing to do, because we can then encapsulate them, put them into small particles, all right, and freeze them and just throw them out in space. And then you have a whole universe populated in the construct of a human intelligence or superhuman intelligence. So in terms of spreading a desired form or forms of life throughout a vast space, cosmic space, then that you could really think of it and intellectually sort of figure out a way of doing that. The universe itself, how that could also be created or constructed and so on, that's a much deeper question. And that's a question that I think is at the heart of every religion, isn't it? I mean, if God created the world, what did he create it from, and so on? And that kind of question, the first prime mover, these questions arise. And they are open to many interpretations, and you can't really deny any of them as being utterly impossible. And the simple answer is that we just do not know, isn't it? We are here, the universe is here, we know that we move around, we know that life is very easily moved around, and the best we can do is to try to understand how we ourselves got here and make the best of the world that we find ourselves in. And I think that's the role of any honest scientist. Not also, we should not be preconditioned or prejudiced by long lines of philosophical thought that essentially has been constraining science for far too long. And we had that, the example of the Copernican revolution, the Aristotelian dogma of an earth-centered universe, and that was a very hard thing to shift. It ultimately shifted. But then the idea that that life is centered on the earth still continues to dominate the whole of our society, the whole of science and the whole of biology. So I think we have to really think seriously, think honestly about the facts that are available to us. And considering the state of the world at the moment, I mean, it's in a dreadful state, isn't it? We are fighting, we are killing each other, we are developing nuclear arsenals at a fantastic pace. We probably have enough nuclear power to sterilize the entire planet at the present time. So what's going on? I think we have to really honestly rethink the whole of our perceptions of science and take things forward rather than rely on antiquated philosophies and antiquated perceptions.
Well, that's very profound insight. We've come to the end of our webinar here. I was wondering, are there any points that you perhaps had wanted to raise about the cosmic womb, or any other subject that you had not had the opportunity to raise yet?
No, except that accepting the correct point of view, albeit in a limited way. I think we really cannot claim that we would understand everything about life, but I think what we know about life and know about the evolution, the progression of life on the earth, means that the possibility of pandemics arising from outside has to be taken very seriously. At the present moment, they are ignored. The evidence is there all around us. And if we continue to ignore this kind of evidence, then I think we are heading maybe for total destruction of our entire planet or entire species. So we've got to take seriously the facts. I think that's the message I want to leave you with. I think facts are the most important. And at the present time, we know that there's a huge resurgence of lots of viral diseases. The Zika virus has threatened species, and it's also frightening that the Zika virus is apparently could be seen as a retrogression of human evolution. It's a situation where you have deformed offspring with diminished cognitive abilities, with smaller skull sizes, and so on. And this virus is sexually transmitted, which is very scary. It's the potential of the whole of the human race becoming essentially going back in time in terms of evolution is really a very serious one. So we have to consider this in a very serious way, to consider the possibility that these are coming from space. If they're coming from space, can we stop them coming from space? Can we have a surveillance program of the upper stratosphere to give us forewarning of future pandemics and so on? And these things have to be taken very seriously. I remember Arthur Clarke saying that the extinction of the dinosaurs became extinct because they did not have a space guard program. If they had this program to look at the skies, look for their safety, look at the skies for their safety, we have a space guard program now that has been set up after the last comet, which is fragmented, which is a comet called Shoemaker-Levy in 1995. And now we have a space guard program to look for small comets and asteroids that might be hurtling towards the Earth. But even more than for comet impacts, I think we've got to survey the upper stratosphere, the environment of the Earth, for incoming viruses that could be damaging, genetically damaging, and causing diseases.
Right. Well, I certainly want to thank you for taking time out to be with us today. I know that this is in many areas, highly contentious field, as you yourself have stated. There are many people who say that, the area of viruses could be the area of biowarfare as well. So I just wanted, for our listeners' sake, to mention that. However, getting back to your field, I believe that the insights and discoveries that you made early on, that space is in fact filled with biological material, including, and I would just mention it again, C60, the Bucky ball, as they call it after. I've met both Buckminster Fuller and Arthur C. Clarke. So those are two kind of key figures that bring together the Panspermia research along with yourself. I would link yourself, Arthur C. Clarke, and Buckminster Fuller as three persons that are leaders in this field around the C60 molecule, because all of the research that I've seen is that, and I'll send you some of the articles and interviews that we've done on C60 to see if it resonates with you. Yeah,
I think it's very important. It's a very important molecule. I think the whole story of life molecules, life-related materials everywhere in the universe has to be taken seriously. And it's just perverse to have so much data and for people to turn away from it.
Yeah. I'm very glad that you said life molecules, because our sky search or scan, as you called it, should also be on the life molecules. Like,
of course, yeah.
Because I believe that just because I've started taking some of these C60 in infusion, and have noted tremendous positive health effects.
Yeah. Okay.
Yeah. And
can we buy it in the drugstore?
I'm sorry?
Can we buy these in the drugstores?
Well, no, not as yet, but you can buy them on the internet. There are many, and these are by, they're sold by scientists who have opened up their own companies. And so you sort of have to go around the pharmaceutical industry.
Yeah.
But and that's the result. And in the interviews that I will send you, one of the gentlemen who's a scientist talks about this panspermia origins of the C60 molecule, even though his focus is on the health benefits of the C60 molecule, including longevity.
Yeah.
So it's a very...
You've been looking for that for a long time, isn't it?
I know. So I'm going to send this to you, and there's some scientific articles appended to the article. So I'd be very interested in your comments on that.
Yeah.
And your insights.
Elixir of life. Elixir of life.
That's it. C60, the elixir of life. Possibly, who knows?
Yeah.
So, and it came from outer space.
Yeah, great. So, that's a good conclusion. Yeah. So panspermia is correct.
So I just want to commend you and thank you for your essential scientific discovery and insight that space is teeming with life, that it's life of many sorts, and that we need to look to it and monitor it and take the best from it and keep the dangerous stuff out. So thank you for that. And we look forward to your joining us again in the future as events develop.
Thank you very much. Thank you.
Certainly. Okay.
Okay, right.